Newton's Laws of Motion by Kabir Peshawaria. Me. Introduction to the Heroes. Hi, my name's Kabir Peshawaria and I'm going to be playing the role of Luigi. And as you all probably know, this is my brother Mario. We are going to teach you about Newton and his laws of motion. Mario is now going to hit me with a fireball. Ouch. It's more painful than you look, you know. It took Mario's fireball 3 seconds to hit me at a speed of 14 meters per second. If time multiplied by speed equals distance, then 3 seconds multiplied by 14 meters per second equals 42 meters. This means that Mario must have been 42 meters away when he launched his fireball. Now we are going to try this again. If Mario is 36 meters away from me, and it takes him 4 seconds to hit me, how far away is he? As you know, the formula is distance divided by time equals speed. 36 meters divided by 4 seconds equals 9 meters per second. This means that Mario shot his fireball at 9 meters per second. Pow. I'm now going to let Mario hit me one more time. If time equals distance divided by speed, and Mario's fireball hit me from 64 meters away at a speed of 8 meters per second, then how long did it take to reach me? Time equals 64 meters divided by 8 meters per second. This means that it took 8 seconds for the fireballs to reach me. Now for the first law of motion. The first law of motion states that an object in motion will always stay in motion, and an object at rest will always stay at rest. But there is an exception to this rule, unless acted on by an outside force. That means that an object in motion will change in motion or stay at rest if acted on by an outside force, and an object at rest, if acted on by an outside force, will start its motion. Let's assume that there's a coin out in the middle of space, and for some reason my brother Mario, you never know what he's up to, is outside in space with it. He's always collecting coins. If he jumps up and hits the coin will start moving. This coin would never stop moving unless it hits another force. For the sake of awesomeness, let's use an alien. Once the coin hits the alien, it would stop moving. That concludes the first law of motion. Now for the second law. The second law of motion states that force equals mass multiplied by acceleration. Okay, I'm gonna pick on Mario again. If my best friend forever, Donkey Kong, were to attack Mario with 500 kilograms at an acceleration of 5 meters per second, Mario would be hit with 500 kilograms times 5 meters per second, 2,500 newtons. Poor Mario. Mamma mia! The third law. Every action has an equal and opposite reaction. Have you ever wondered why Bowser is able to jump so high? I'll tell you why. Newton's third law of motion. Bowser is a very big fellow. If he pushes down on the ground will have an equal force exerted on him, pushing him miles high into the sky. As you can see, he's pushing down 4,000 newtons of force on the ground. And the ground is pushing back an equal 4,000 newtons of force. Look at how high he can jump. Thank you. That concludes my science lesson for today. My sources were Mr. Anders, my science textbook, Google Images, and my brain. The end. Come to our next science class. See you next time. Kabir Peshawaria and the Mario characters signing out.